Hey, hi, good evening, everyone. Good evening, friends. Welcome back to our 20 days short term training on Power BI. So, friends, we have successfully completed 5 days of our training, so which includes the important component of Power BI. It's Power Query Editor, right? So, so today we are going to start a new component of Power BI called Power Pivot. Okay, so before we start Power Pivot component, we'll quickly recap what we have understood in the last session. Then, you know, we'll start the topic for the day. Right. So I have to completely assess new file. But before that, anyways, so under Home tab, we have an option like Transform Data. So if you select or if you click on Transform Data, Power Query Editor launches, friends. We have understood all the options. I mean, majority of the important options were being covered as part of these 4 days on Power Query Editor, right? Yes. So Home tab, Transform tab, Add Column tab, and View tab. Okay, so these are the four important tabs under Power Query Editor, and this Power Query Editor component helps us to prepare the data set for the next process. I mean, uh, if you want to do some kind of cleaning activities and say if you want to transform the data, Power Query Editor helps us to, you know, this particular component helps us to perform all the steps. So under Home ribbon, we have all small, not that much used options, but still these are important. But if you see here, append queries and merge queries, both of them are important. So merge queries is representing joins, SQL joins, and append queries is representing union all operator, union all operator in SQL. Then under transform ribbon, we have extract, group by, pivot and pivot, then transpose. Okay, so we can also count the number of rows. We can perform any kind of steps on numerical columns, date time columns, and all. Yes, the same or majority of the columns options that are present under transform tab will be available under add column tab. They are also available under add column tab. So the difference between transform tab option and add column tab options are, uh, when we try to use any option that is present in transform tab, the output replaces the original data. So the output will be saved in the same columns that were being used. Whereas under add column tab, if we use any kind of option for doing any specific task for fulfilling our requirement, add column tab makes sure that the output is going to store in a new column. It returns the output in a new column. So that makes the main difference. And here the same options are also available, friends, from text, from number, from date, time, and all. Then the widely used or the important one are conditional column. Based on conditions, yep, we can create a column, and also based on examples. Okay, so by specifying an example, Power BI being intelligent, it tries to capture the pattern and it fills all the rest of the records, all the rest of the rows with the same pattern that was used in the first row or the first record for the first cell. Okay, so these two are important, and under view we can get the information about the data, the quality, the distribution, the profile, and all. So I'm not going to extend much about Power Query Editor because we have understood till the depth of each and every tab that we have focused in the last 4 sessions, right? So folks or guys, whoever have skipped these sessions, sincerely request them to cover these sessions, then join, then start listening to the ongoing lectures. Right. So we have successfully completed the first component of Power BI. It's Power Query Editor. Now, today we are going to start a new component of Power BI. It's Power Pivot. So Power Pivot, yep. Power Pivot is used for data modeling. We can create models. What do you mean by models? Okay, first of all, what do you mean by model? Friends, we'll understand everything. Okay, so this is a model, and if you see these boxes, the rectangular boxes, they represent tables. They represent tables, and there is some kind of connection between the tables. Yes. So this can be done using Power Pivot, and in order to look out for all the models, we have to go and sit in model view. But before we talk about this data modeling or before we do hands-on, first we have to learn what is this data modeling and how does it help us to create models, right? Yes. So for that, let me take, okay, I'll take the same sheet now. Hmm. Let me take an empty Excel sheet. Guys, focus because this is something that you're going to, you know, uh, learn interesting and the important topic. Okay, so in real world, generally, people face the same issue, and how the issue is handled using Power BI, we are going to learn today, friends. Right. So data is generally stored in two ways. Okay, if you take structured data, the best way of storing the data, structured data, is in normalized fashion. What if the data is stored in denormalized fashion? We have to simply make this denormalized data converted to normalized. That is a process. But what do you mean by denormalized data and what is the meaning of normalized data? That is a question, right? So let us talk about denormalized data because no one or no organization they store their data in denormalized way. The reason is if the data is stored in denormalized fashion, it it is going to result us in some kind of anomalies, errors. Okay, so let us talk about this denormalized fashion data. What is this denormalized fashion? If that is your question, okay, just give me a minute. No. Okay. Right, anyways. So, what is the meaning of denormalized fashion? I'll take a small data set, friends. Okay, so there is a small organization, and the data in the organization is stored in this fashion. Okay, so I'll give it as employee ID, then employee name, then what else? Employee department, then employee or department, say manager, and department, some kind of ID. Mail ID probably, yes, because this changes from department to department if I'm not mistaken. Am I right? Yes. Right. See, friends, employees. So assume that this organization have say 5 or 6 folks. So one, and this guy name is A, and uh, this guy works for sales department, and you know this guy's manager name is Priya. Okay, and the department ID is say XYZ at the rate say sales. Okay, some company name dot c company and then sales dot com. Okay, so assume this is just a dummy data, but still in this fashion we have the data. So I'll also have the rest of the folks. Yes, 2, 3, 4, 5. I'll quickly give the names B, C, D, E. And all these five folks, they belong to the same department. All these five folks belong to the same department. And even so, if they belong to the same department, will they have different department manager? No. The department manager will also be same. Then their department, sorry, department ID will also be same. Yes, ID will also be same. Now the question comes, do you feel like the data is getting repeated? If you see this data, if you observe the table properly, do you feel like, there are some values, there are some columns in which the data is getting repeated? Yes, yes, Akhil. What are the columns, friends? I see department. Department. Name of the department is getting repeated. Yeah. Then department manager is also getting repeated, Akhil. Yes, yeah, right. Department mail ID is also getting repeated. So, in simple, I can say that by just looking at this data, you know, the data in this table, in this particular query, is stored in denormalized fashion. Again, we are using the same word. What is this denormalized? This is actually containing, the similar data, the similar values. Time again, it is getting repeated. This is called as redundant. The data is stored in the form of redundancy. Okay, the same information is being stored time again. Should I prove it? Yes. For example, let us assume that the same organization have hired a new person in the same department. Sixth person comes in, his or her name is F, but these three values will be same. Yes. So even though if a person comes into the same department, what I observe is department, department manager, and department mail ID is getting repeated. So what I can comment here is, it is actually when I'm trying to update or when I'm trying to insert a new record. Okay, so when we hire new people, obviously I have to update their values. I have to insert their values into the same record. So when I try to insert these records, this redundancy is getting more. Yes. So it is creating some kind of insert anomalies. Then okay, what say you know if the department manager have left the organization, department manager left the organization and some other person have joined the same company, this company XYZ. Okay, so I have to update the department manager. Yes, for the sales department, whoever the manager have joined the organization, I have to update in the entire column, not in a single position, not in a single row. In the entire column, I have to update. So this is actually creating me an update anomaly. Am I doing it in one specific record? No. Since all of these folks, they work in the same department, for all of these, the department manager will be same. So I have to update in this entire manager column. So obviously it is, creating an update anomaly. Okay, fine. At some point of time, you know, our employees got frustrated against the management and one by one started leaving. Assume that one by one started leaving the organization. Okay, if one person left the organization, what I'm supposed to do? I'm supposed to remove or I'm supposed to delete their records from the table. Then initially F left, so I'll remove F. Then E person left, I'll remove E's details. Same D, C, B, A. Assume this is the worst case, but assume. So if this happens in the organization, if all the employees present in a department, okay, if they are leaving one by one, and if I remove their details, what's happening to the data? Obviously, I have to remove all the records. But one thing that you observe is, do you have the information for sales department manager? No. Why? Since you have removed the entire data, okay, since we have removed all the records, it is also removing the information of sales department manager, right? So this is creating me delete anomalies as well, delete errors as well. So especially, if you are aware of SQL concept called, commands. So under the commands we have, DDL, DML, data manipulation language. There are three different commands: insert, update, and delete. Okay. So if your data is stored in this fashion, where it is occupying more space and where more duplicates are present, okay, it will create some kind of anomalies. Okay, and here is the explanation for those anomalies. So since in order to ignore these anomalies, this kind of data is nothing but denormalized data. The data is not present in a normalized fashion. Okay, because the data is present in denormalized fashion, it is creating some anomalies, some errors. So what I can do is I can convert this data into normalized fashion. Is it possible? Yep, it's possible. How can I do it? Simple. Break this table into n number of tables so that your data which is denormalized, because data present in denormalized way, it is creating some issues, right? It is creating some errors, right? So for that reason, I'm converting the data which is present in denormalized way to normalized way. Okay, what is the meaning of converting normalized? uh, what do you mean by normalized data? Nothing. I'll bring this redundancy to low. So whatever the values that you see that are getting repeated, let us bring them down. Okay, and make sure that these errors or these issues should not repeat. That's nothing but normalized fashion. I hope you got my point. So let's understand how denormalized data will get converted to normalized data. Okay, for that I'm breaking this table. I'm breaking this table into two parts. I mean two tables. So for that, you see, I'm copying the data and I'll paste it over here. I'll go back. Sorry. So this is the other one. And this is nothing but, you know, normalized data, and this is denormalized data, right? Akhil, how did you do that? Simple, I'll tell you. See, now let us also understand, are these issues got fixed or not? Okay, first thing, I'm saying the data is being, stored in normalized way. So let us check whether the data is stored in a normalized way or not. For that, I'm creating two tables. The first table is called as employees table, and the second table is called as department table. Okay, employees table is the one, and the second table is department table. Okay, for that. Hmm. So, first issue, that whatever we had, what is the first issue? Insert problem, the insert anomaly. If a new person comes in, if we hire a new person, okay, what's happening? Am I repeating more number of values? Am I repeating more number of, column values like in previous case? No, I'm just repeating only a single value, that is called sales. So what happened? This redundancy that we have, the data which is getting repeated with 4 number of times, it got reduced. I don't say it as zero, but still, instead of storing or repeating 3 columns for the same number of times, it's better if you repeat only one. So even if a new person joins, I repeat only sales column. The department column values, that is sales, will just repeat. So one thing that I can see is the redundancy with respect to the data, the duplication, okay, which is actually occupying more space. In the previous case, got reduced. Okay, it's got sorted. Now the second one, update. If my manager for the sales department, was changed, instead of Priya, some other, say, some Ram has joined. Am I going to update in all the places? No, I'll just update in just one record. I'll update in this particular table called department. So is my update anomaly got treated? Yes. Then you also see delete. With respect to delete, even though if all the employees leave, will I lose the information of the department? No. For sales department, I have the information who is the manager. Because even though if I remove the records from this table, that doesn't mean I'm removing the data from this table, right? So the data in department table will be as it is, intact. Okay, so all the three anomalies that we face in denormalized way data, if the data is stored in denormalized fashion, will get treated if the data is stored in normalized fashion. So in general, in real world also, data will be stored in normalized fashion. The reason is, if you store data in denormalized fashion, it results as in some anomalies, some errors, and moreover, the data will be stored in redundant format. Okay, it occupies more storage. So this is not accepted in real world. So what we do is we convert the data into normalized data and we store it in multiple tables. Okay, multiple tables. So this entire process, whatever we have just learned, okay, we'll do the entire process only using Power BI, friends. Will not go and touch any other tool. Okay, only using Power BI we can build these models. So this is a table and this is a table, employees table, department table. Okay, so we generally name these tables. So this department table that you see is called as fact table. This is called as fact table. What do you mean by fact table? Fact table means the table which we generally, change very often, very rare. If we are changing a table's data, the data which is present in a table, very rare, it is called as fact table. And what is the other table called? It is called as dimension tables. What is the meaning of dimension table? Opposite to fact table. Dimension table is the table in which the data gets changed, on day by day, or say it's not that rare. Okay, for example, you tell me out of these two, which will be dimension? Obviously, employees. Yes, because employees can be hired, can be fired, anything can be done. So if a new employee comes, I have to change it. Or if I fire an employee, I have to remove the details. So in general, this becomes employee table becomes the dimension table. We'll change it, probably on monthly, or say depending upon the requirement we change. But fact table is a table in which the data will be changed very rarely. So you tell me when this data inside this table gets changed. Only if the department manager changes. So you tell me, will the company, hire n number of managers for a department? Probably no. And these managers, when they walk in or when they get hired, they'll try to, stay back for a long time. Okay, it's not like employees if they get some other, say, an offer they might leave. For manager, if you are at the manager level, once if you are at the manager level, it will be like a tough competition for you, right? So if you are at junior, or if you have started your career just at the starting stage, then you can find more opportunities. So in general, this becomes our dimension table, and department table becomes our fact table. And we try to create some relationship between dimension table and fact tables. And that particular relationships creates a star schema. That particular relationships are called as star schema. So I hope everyone is aware of star. So what we observe during nights in the sky are nothing but stars, right? So in the shape of star, we'll have this entire models. So that is the reason it is named as star schema. And in general, in star schema, we'll have only one fact table and multiple dimension tables. We can have multiple dimension tables. Okay, and the relationship should be established between fact table and dimension table. So if you see, I can establish a relation between employees and department. How? Using department column. This is the matching column, common column. So using this column, I'll create a relation between dimension table and fact table. Okay, and these relationships are of four types. There are four types. Probably you might have heard them. One, let me give this way. One to one relationship, then one to many, also called as many to one. So both are same, and finally many to many. So these are the different relationships that we have, you know, that we can establish between these tables. So the best example for one to one. So if you take one to one relationship means there should be only one kind of relation towards, forward and the backward. So let me take two tables. In the first table, I have uh, all the 150 crore population of India in one table, and in the second table I have probably their Aadhaar card numbers. Yes, now tell me what kind of relation you find between our people and their Aadhaar card number. Per one person, we should have only one Aadhaar card, right? One number. But what if a person is having multiple Aadhaar cards? So again, they'll put in jail. They'll put him or her in bars. So that is not accepted. But if you talk in reality, so this is a one-to-one relationship. Person with Aadhaar number. Okay. So in the first table, I have all the person names, all the people names of India, and in the second table, I have their Aadhaar numbers. So what kind of relation can we have? If you take any one person from the table one, okay, how many Aadhaar numbers he or she can have? Only one. So it's a one relation towards, if you go in the forward direction. Even if you take randomly any of the Aadhaar number from Aadhaar number table, so it will be related to only one person. Again, it is again one kind of relationship. So it is one to one relationship. I hope you got my point, right? Then one to many or many to one, both are same because if you just interchange the tables, you can establish either one to many or many to one. Okay, so that is the reason if I explain one probably well, we can just take the same example for the rest as well. For the next one, one to many. So let me take students with subjects. So this is the actual problem that we face being a student. If I take students details in one table and the list of subjects, that these students have to study in the next table, two tables. One is students table and the second table is subjects table. If I randomly select one student from the students table, so a student should study how many subjects? All the subjects? Yes. So one student is related with n number of subjects. Then you go back to the reverse direction. You take any one of the subject. So this is one to many. If I take the same example and if I reverse them, subjects with students, just replacing their position. Okay, so students being on the right hand side, they have to study all the subjects. Yes. Then when I take us to especially one subject, it has to be studied by all the students. Now comes many to many finally. Am I right? So many to many, this is with doctors. Doctors table or doctors details with patients. A doctor has to treat n number of patients, many patients, yes. Even if a patient is suffering from n number of diseases, okay, so this same patient should be treated by different doctors. So it's a many to many relationship. Okay, so all these relationships we generally have to have some kind of understanding so that it will be easy for us when we do the same thing in Power BI. Okay, so for that reason, especially this point, converting the denormalized data into normalized data, then establishing the relation between fact table, dimension tables, everything, and finally viewing these relationships in the model view is the part of power pivot component. Is the part of power pivot component. So what I'm doing is I'm taking a small data set. Okay, it is not that much small, but still try to understand. In total, there are many columns, and if you observe here, friends, there is lot of data which is stored in the redundant manner. Okay, so data is stored in the form of redundant manner, and we are supposed to, convert this data into normalized way. Okay, so I'll give you some enough time, and you are supposed to tell me what kind of, you know, dimension tables that we can come up with. Identify the fact table and identify the dimension tables also. But before that, let me explain about this table. So this table is of some kind of sales that a company, okay, so there is a company, and this company has n number of products. So all the product names are here, okay, their product IDs are here, and within, you know, if there are some products, obviously customers walk in and they'll purchase. So we also have the customer details, customer IDs, and customer names. Okay, so in this column, everything was being recorded in the same table. Then the same company was opened in different stores, I mean, with the different IDs. So store IDs were also recorded. We have the information about the stores, store name. Okay, so if you see, both of these sales are from the same store, downtown depot and downtown depot. Okay, then date ID as well. So date ID is representing the date. So 29th of Jan 2023. So with respect to date ID also, we have some kind of columns. Date, okay, what day it is, it's Sunday, which month, Jan, what is the year. So we have just broken it. Okay, so this is how the data is, and I can clearly say that the data is in non-normalized fashion, denormalized fashion. So we have to convert this denormalized fashion data into normalized way. Okay, so we have to convert this normalized non-normal data into normalized way. For that, I'm going to load the same data into Power BI. Okay, then I'll continue my journey. So what is the first step? The first step is importing the data. So it's Excel workbook, and the home tab, select Excel workbook. Then go and identify where the data is residing. Select the workbook. Then click on open. Yes. The moment I clicked on open, navigate the same process, friends. Nothing new. So I'm clicking on sheet one. There is only one sheet in this data. So this is the preview of the data. Okay, then should I click on load or transform? Always make sure that you click on transform data. The reason is, it's better if you go and have a look regarding any kind of cleaning activities or transformations to be done. So I'm clicking on transform data. Okay, so it launched Power Query Editor. We have Power Query Editor launched, and this particular sheet have 31 columns. There are 31 columns and 100 rows. Okay, and now it's our turn to convert this non-normalized data into normalized data. How can we do that? Is we have to use the same logic. This is the data that we have, and we are supposed to bring into different tables. So Akhil, let us break the table. Sure. We'll break the table. But how many tables? Why don't we bring a separate table for products? Why don't we get a separate table for customers, for stores, for dates as well? So that, you know, the data which is present, see, product name is water bottle. Can I get the same water bottle repeated at any one of the time? Probably. Okay, see, it is repeated. Can we reduce it? We can. When we keep a separate table for product only. When we create a separate table for product only, what we have done here, I know that department details can be recorded in a separate table. So for that reason, I have created a separate table. with department name, department manager, and department ID. So why don't we create one table for products, one table for customers, one table for stores, one table for tracking only the dates, and then let us focus on removing the duplicates. Okay, right. For that, what I'm doing is, first of all, you know, I'm creating duplicates of this table, of this query. Okay, how to create duplicates is, right click on the table name and click on duplicate. This will create duplicate query. Okay, so actually I also have reference, right? What is reference and duplicate? Duplicate means it is just like the same, the previous one. But reference means it will refer to the same sheet again and again. If you create any kind of changes in the sheet, and if you create any reference sheet from that particular sheet, whatever changes that you do in the previous one will be reflected in the same referenced one. So let us not go with the reference, let us create duplicates, because duplicate sheets, they are completely different. Okay, so here I'll try to keep only product related columns. For that, what I'm doing is, under home tab, you see choose columns. So yes, let me choose some columns. So I'll go through these columns. First, let me unselect all. I want to keep all the columns of product. Product, product, product. From here, the product column starts. Product name. First, the product ID we have, then the product name, then the category to which the product name falls under, the price of each and every product, who is the supplier of the product, then stock quantity, what is the stock quantity of each and every product, and the rating that we get for this product. So these are the columns. Next to that, we have store name. So store name is something related to stores. Anything else? Nothing. Customers, these are customer related and this is date related. That's it. So I'll just click on OK. This will result me in only the columns of product. Only the columns that are related to product we have, in the sheet 1 of 2 in this query. Now, if you observe, do we have duplicates? Yeah, Akhil, I think we have duplicates. Just cross check. This is 110. Product ID is 110. Or just let me, arrange in ascending or descending so that we easily understand. See, I have, I can clearly see that we have duplicates. Product ID 101 is repeating for 5 times. Same. The record is same. Supplier will be same. Stock quantity will be same. Rating will also be same. So what I can do is I can remove duplicates. I'll go to remove columns. Sorry, remove rows. Then I'll click on remove duplicates. See friends, 100 rows will convert into just 20 rows. 100 rows got converted to 20 rows. What happened? What happened is duplicate data got removed. Okay, and this table talks about product details. So I'll name this as product table. So let us create similar kind of uh, names, similar kind of tables for rest of the names. So product ID is done. I mean product table is ready. Now let me create one more duplicate for the same sheet. Yes. So I have created one more sheet. Now let me create a table for customers. The same process. I'll choose columns, whatever is required, unselect all of them, customer ID, then customer name. Yes. You see here the customer name. Next to customer name, we have customer gender, customer age, customer the city they belong to, their membership level, and what is their spending score. What is their spending score? Anything else? No, nothing else. So I'm creating a separate table for customer database. Customer database. And you see only 7 columns, 31 columns. Out of 31, only 7 columns belong to customer. And from this, again, the same process. First of all, let me understand, do we have duplicates or not? Right, if you click on this drop down, if you sort in ascending or descending, you'll understand. See, customer ID is 207 and their name is Todd Lamb. Okay, and she's a female. Okay, her age is 30 and her city is New York. So what I can see is I can observe duplicates. So let us remove the duplicates, friends. Process is same. So 100 rows, out of 100 we have 32 duplicates. So all the duplicates got addressed. So I'll rename it to customer table. Done. Customer table. Then next to customer table, what else can be created? I'll create one more table, duplicate of the sheet. Let me create a table for only store IDs. Okay, stores. So I'll click on choose columns. I'll unselect all of them. Then store ID is the first one. Then store name. Yes, from here the columns of store belongs to. Okay, store location, store location manager, and when did they open this particular store? Open year, store size, and the revenue that is being generated from the store. Okay, and apart from that, anything else? No. I'll click on OK. So 7 columns belong to stores. Okay, again the same process. Remove the duplicates. If we have duplicates, it will remove. Yes, 31 rows, 31 duplicates got removed. And this I'll name it as store table. So what I'm doing is I'm creating, I'm just converting the data from non-normalized data to normalized data. Okay, then I'll create one more duplicate of the sheet, and this time I'll just have the data for only dates. Okay, so the columns to be selected, unselect all. So date ID is the first one, and I can clearly see, yeah, probably from here the date on which the transaction happened, on which the sale happened, and the day of that particular date, the month, year, whether it's a weekday or not, and what is the quarter it belongs to. So all of these columns belong to dates. Done. And let me remove the duplicates. Duplicates removed. 100 out of 100, only 30 means 70 duplicates are removed. 70 duplicates are removed. But one thing that you observe here, is everything perfect? Yes. ABC, everything is okay. So what I'll do is I'll rename this as dates table, some kind of table. So all have been created. Now let me go to the original data. The original query. So in this table, if you see, a table for dates has been created, a table for stores has been created, a table for customers, products, everything got created. Only we did not create a table for sale ID because this will become our main table. Okay, then using these columns, product ID, customer ID, store ID, and date ID, we'll connect to rest of the tables. So let us not touch these columns. What are the rest of the columns that we have? Quantity and total amount. This is part of sales. What are the total quantity that was being taken from the customer, and what is the total amount in dollars. Okay, so these also will be part of sale ID table. But if you observe, we can remove the rest of the columns. Rest of the columns can be removed. Why? I'll talk. So all these product ID, customer ID, store ID, date ID will be used to connect with the rest of the four tables, being primary keys, and quantity and total amount will talk about the sale of that particular order. If you see rest of the columns, all of them I have it in rest of the tables. So I need not have them here. I'll click on OK. 7 columns is what I have. Can I have duplicates in this table? Let us also check. So I'll try to remove the duplicates based on a column. So seems like there is no duplicate because each one is talking about a sale. ID will be different, right? For every sale ID, for every sale. So obviously there will be no duplicates in this table, and I'll rename it as sales or fact table, probably whatever it might be. Now my data, which is in this fashion, where the data is repeated, where the data unwanted data, I mean the same values are repeated for any number of times. But if you see here, is the data repeated in the same fashion? No. The denormalized data, the non-normal data got converted to normal data. How? We just broke the table into 5 tables. Once if you are done with this, Akhil, is this what you are talking about, the modeling and all? No, we have just completed the preliminary steps, the cleaning steps. Click on close and apply. The save changes, it completes and it applies to store data to Power BI desktop. Okay, so it gets converted to Power BI desktop. The data gets loaded to the Power BI desktop, and I'll show you the relationships. A few minutes. Okay, it's taking time. It's loading all the tables. Done. So once after clicking on close and apply, you'll find all the queries down of data pane. So just go to model view, friends. See, did I do anything? Nothing I have done. But Power BI being intelligent, it identifies and establishes the relationships. You see, it identifies and establishes the relationship. So I'll arrange it in proper way. So we are talking about star schema. Yes. So let me arrange in that fashion. Star schema. Something like this. And probably like this. Yeah. You see, I'll reduce. See, Power BI have identified the relationship. How can you tell that I did not do anything? See, I just applied, have closed Power Query Editor, and I have applied the changes to Power BI desktop, and we just moved to model view. Immediately, you know, it have identified the relation between the fact table and the dimension tables. See, and whenever you are trying to hover your mouse on the relationship, it is also identifying the column that was used to connect. Date ID is being used, product ID is being used here, store ID, customer ID. So you can adjust it as per your wish. Here also you can adjust. So what, Akhil, what if Power BI did not identify any kind of relationship? Assume the worst case. One thing is under Home tab, you'll see Manage Relationships. Okay, click on that and you try to click on this Auto Detect option. It identifies, I mean, Power BI identifies the relationships. If not, you have to create the relationship manually. In some cases it fails. Okay, so click on new relationship. Okay, then select the table on which you want to create the relationship between the tables. Okay, then select the column and you are supposed to give the cardinality. What is cardinality? Nothing but the relationship. Is it one to one, one to many, or many to one, many to many? You have to define. Okay, this has to be defined. But if you see, Power BI have done that, so I'm not need not worry about this. Even if you right click on the relationship, you'll get delete and properties. Two options. Delete is for deleting, uh, you know, deleting that particular relationship, and properties option is for editing the properties. You can edit the relationships. Okay, so we'll talk a bit more about this. Assume what kind of relation we have between store table and our fact table. Okay, store table and fact table have one to many relationship. The star mark that you see is talking about many. Since there is no or a bit here, yes, one to many. Okay, so this is talking about one to many relationship. We have one to many relationship between store and fact table. The same with customer, the same with dates, the same with product table, everything. Why it is one to many? If you take product ID, okay, if you take one product ID, you can have multiple, the same number of, the same product ID will have multiple in fact table. Yes, this is representing sales, right? Sales table. So a product can be purchased by n number of people. So it gets repeated. But if you take only, if you take any one of the product ID from fact table, you will find only one in product table. That is many to one with respect to fact table and product table. But with respect to fact table, product table and fact table, it is one to many. In the reverse direction, it is many to one. Okay, right. So this assume, this is nothing but data modeling, friends. We will create a model like this, and using this, we'll create some kind of visuals. Okay, let us create some kind of visuals. I take uh, probably from product table, yes, let me zoom it to the max. Product ID is what I'll take for one in the first visual. Then next to product ID, I'll take product name. See, Akhil, you're just selecting the field. How come a visual got, appeared in the report view is under visualizations pane, by default table view will be used. This is an interview question. Which visual under visualizations pane is the default visual? So in general, if you want to use any of the visual, you have to go to visualizations pane and use it. But without using any visual, if you just click on the fields, the columns, by default table visual will be used. This is called as default visual of Power BI. Okay, so I'm also going to use price. I think this is good enough. So the clear information. Do I have the clear information? Yes. The product ID, product name, price. Okay. In one more table, let me go with fact. I'll take product ID and I'll adjust it. So we can adjust these, friends. I'll talk about these more about visualizations and all in the coming topic, not now. Okay, this is topic of data modeling, right? So I just want to explain a small, there is small topic that is left out. And for that reason, I'm using some visuals. Okay, I'm using product ID from fact table, and what is the total amount that we got from that particular product. So I'll talk about these two. Right. This visual one, This particular visual was created using product table, and visual 2 is created using fact table. Okay. Okay. Table visual is not the default view. It's called default visual of Power BI. Default visual. Okay. Even if you don't select any of the visual, okay, by default table visual will be used. That's what happened. This is called as table visual. So now my question is, I can see product IDs in both the tables, both the visuals, but product name is part of the product table. So I have used it in the first visual. And what is the price of each product, individual product? We have it in the dollars. And in the next visual, we have the total amount. What is the total amount that we have got so far from each and every product? Assume I want only, I want the price of, or what is the product for product ID 110. Okay. So when I try to click on this, is it interacting with the rest of the chat? I mean, the next chat? No. But let me do the same thing on chat 1. Did it interact? Yes. It interacted in one way, but in the other way, it did not interact. See, depending on the product that I select, it's interacting with the next visual, the next chat. But why it is not interacting in this way? This is because of cross filter. Okay, you see arrow mark? Because of one direction, the charts are interacting only, if you are selecting the any of the row from product table, it is interacting. But if you are selecting the same, product ID from fact table, it's not interacting. That is because of the direction. So make sure the direction should be both, not single. You have to make it both for all. This is for store and fact table, right? For product table also, you have to keep it as both. Only then it will interact in both the ways. See, now it got changed in both the ways. I'll go back. Now it started interacting. In either of the ways, it interacts, friends. Why it did not interact in the previous case is because of cross filter direction, an important topic in data modeling. If you don't remember that particular topic, by default it creates only in one direction and the charts does not interact. But if you see here, it's interacting. See, I can get the complete information. So that's how we are going to use the next topics for data visualization. But this is how we create models in Power BI. The denormalized data, the denormalized data got converted to normalized data, and we were able to establish the relationships between these tables. And once the model is ready, we can use it for visualizations. Okay, so it's an important component and a topic in Power BI. So that's all for the day. And you know, in the coming on the coming day, we'll start with a topic called DAX, data analysis expressions. But before that, you take any non data which is in denormalized way and try to make it normal. Okay, so by using this Power Pivot component, just follow the same steps. Just follow the same steps and convert the data to normalized fashion, and use it for your visualizations. If you are facing an issue, as I have told in the previous sessions, use comment section. In the comment section, keep all your uh, you know issues or errors. Right. So friends, Any technical questions or any casual questions? So the feedback link has been provided. Before you leave, I request you to hit on the like button and also share across multiple channels. Okay, so that folks like us will start learning Power BI, right? So these sessions will be benefited for them in future as well. Right? Any questions? Thanks for your support and all. Upcoming will be like these AI. Okay, if you have started learning AI, say if it does even something related to cyber security or say IoT and all, those will be the upcoming technologies. Start learning those new technologies. Mainly focus on AI friends, artificial intelligence. Sir, in transform, okay, group by is for grouping the data, for aggregating. See, if there are multiple departments, okay, in an organization, they will have multiple departments. And if you want to get the salaries that we pay for different departments, okay, so for sales department, how much will be the salary? So you are grouping the entire data. You are going to add all the records of the folks, the employees who work in sales department, and that value will be returned. In the same way, say in production, say in XYZ department, you are actually grouping the data, group by friends. Okay, right. So that's all for the day. I'll meet in the coming session. Until then, take care, friends. Thank you once again for joining the session and making it interactive. Right. We'll meet in the next session. Until then, take care. Bye. See you. Signing off.